Thermodynamics governs how the entire universe operates, and thermodynamics governs how the entire universe will end. The two laws of thermodynamics are fundamental laws of physics. The two laws of thermodynamics are always true everywhere in the universe until the end of time. The first law of thermodynamics is that energy can never be created or destroyed. The amount of energy in the universe is always constant. All suns and stars have a limited amount of energy. As a star emits light in all directions, it uses up this energy. Energy can be thought of as boxes that are attached to all objects, and that can be transferred from one object to another. These boxes can never be created or destroyed. Faster objects have more energy than slower objects. Energy can hide in many forms. For example, a spring has the potential to move objects. Gravity also has the potential to move objects. Objects at higher elevations have more energy. Objects at higher elevations create more motion when they fall. The energy per particle inside an object is what we call temperature. Since energy can never be created or destroyed, and objects at higher elevations have more energy, this means that objects must speed up as they fall, and objects must slow down as they go up. Energy is not destroyed when friction slows down objects because the friction speeds up the molecules, increasing the temperature. Energy is not destroyed when the temperature goes back down because the motion is dispersed to the surrounding molecules. There is also a hidden form of energy that all life and technology depends on. This is the chemical energy in the food we eat and in the fuels we burn. This comes from the electrons that bond molecules together. Here, they absorb energy. Here, they emit energy in the form of light. A molecule absorbs or releases energy when the bonds between its atoms are created or destroyed. There is another form of energy which is far greater than all of these others combined. Albert Einstein discovered that mass is also a form of energy. Mass is never created or destroyed in any of the reactions we have discussed so far. When certain atomic nucleuses combine or separate, some mass completely disappears from the universe. The energy of this missing mass is then released. Nucleuses splitting apart power nuclear reactors. Nucleuses combining powers the sun and stars. There are many other phenomena that contain energy boxes. Energy boxes are responsible for everything that happens in the universe. However, here's the part that's mysterious. These energy boxes do not actually exist. No one can see, touch, or observe energy boxes. We can only observe things like a car's speed and a spring's compression. We can measure an object's elevation, mass, and temperature. We've learned that when any one of these properties changes, it must correspond to a change in one of the other properties. We've given this phenomena a name. The name we've chosen is energy. However, although we've given it a name, no one really knows what energy actually is. What's even more mysterious is that energy flows backwards in time in exactly the same way as it does forwards in time. There is no way to know that a video is being played in reverse. Even with time flowing backwards, all the laws of physics look like they're being obeyed. If you reverse the directions of the particles and then follow the laws of physics, you'll get the exact same results in reverse order. Even for chemical and nuclear reactions, the laws of physics work the same way backwards in time. Therefore, reactions such as these should be physically possible. Yet we never see them occur. There's only one reason these events never happen. The second law of thermodynamics. The second law of thermodynamics is the only physical law that does not work the same way backwards in time. As one example of it, if you lift the barrier, the balls will permanently spread out throughout the entire box. No matter how long you wait, the balls will never again gather together in one small area. To understand what the second law of thermodynamics says for the end of the universe, imagine the following. We have 5 objects in one sphere and 0 objects in the other sphere. Now suppose that one of the objects is in the other sphere. There are 5 different ways this can happen. Now suppose that 2 objects are in the other sphere. This time, there are many more different ways that this can happen. When there are more ways that something can happen, we give this a name, and we say that it has a higher entropy. This situation has the lowest entropy because there is only one way it can happen. The second law of thermodynamics says that the entropy of the universe can only go up. The entropy of the universe can never go back down. Although there are many ways all the balls can be arranged inside just one sphere, there are far more ways the balls can be arranged with the balls spread out between both spheres. The more evenly the balls are spread out between the two spheres, the higher the entropy. This is why we will arrive at this situation if we wait long enough. This is also why this event can never occur. This would mean that entropy has decreased, violating the second law of thermodynamics. We can try to push all the balls back together again. However, there was only one way all the energy boxes could be contained inside the spring. Entropy has increased because there are many ways the energy can be spread out. Entropy also applies to energy. This is the reason life in the universe is possible. This is also the reason all life in the universe will end. The entropy is highest when the energy has spread out evenly throughout all the particles. This is why heat flows from warmer objects to colder objects until they reach the same temperature. Complex objects can be put together only because energy is added and converted into heat. The dispersion of energy as heat increases entropy. The increase in entropy from heat offsets the decrease in entropy of the objects being put together. Because of the dispersion of energy as heat, the total entropy of the universe has still increased. Suppose we try to violate the second law of thermodynamics and do useful work without dissipating heat. We can use this fire to heat our box and cause the balls to speed up. The balls will push against the wall and stick, causing useful work to be done. At this point, although there's still a lot of energy in the fire, it will not be possible for more of this energy to flow into the box. This is because the box and the fire are now at the same temperature, and heat flows only from warmer objects to colder objects. For more energy to flow from the fire into the box again, we need to first cool the box back down. Now we can continue to use the energy from the fire to do useful work. Eventually, the ice will melt and the fire will burn out. All engines and life forms need to dissipate heat to a colder object to keep operating. However, all objects will eventually reach the same temperature if we wait long enough. When everything reaches the same temperature, no engine or life form will be able to continue operating. Can we think of a way to avoid this? We know how to cause objects to slow down. Suppose we use this to try to violate the second law of thermodynamics by causing heat to flow from a colder object into a warmer object. Energy is transferred from the balls to the spring, causing the box's temperature to become colder than the ice. Now heat flows from the ice to the box because the box is colder than the ice. Suppose we now compress the balls together, causing the box's temperature to become hotter than the fire. Now heat flows from the box to the fire because the box is warmer than the fire. This is how refrigeration and air conditioning work. The ice is getting colder and heat is flowing from the ice to the fire. However, the addition of energy increases entropy, and the second law of thermodynamics is therefore not violated. All refrigeration and air conditioning requires the addition of energy. Suppose we try to create a perpetual motion machine by using an engine to power this refrigerator, and using this refrigerator to cool the engine. Unfortunately, this idea can never work because the refrigerator will always require more energy to cool the engine than the engine can supply. Therefore, the energy that we dissipate as heat cannot be used again to do useful work, and the fire will eventually run out of energy. We can keep the fire burning by adding fuel, such as coal or oil. But there is a limited supply of coal and oil in the earth, and we will eventually run out. We can keep the fire burning by using nuclear energy. Although there is a much larger supply of energy from nuclear reactions, the Earth also has a limited supply of elements useful for nuclear reactions. When we run out of nuclear fuel on Earth, we can keep our engines running by using solar energy from the sun. Although the sun will continue burning for millions of years, it too has a limited amount of fuel and will eventually run out of energy. All life and technology requires an external source of energy. Once the sun has been extinguished and we've used up all the fuel in our planet and in our solar system, we will have to go into space to find a new home. Here, we will once again have plenty of energy from our new sun, and there may once again be lots of fuel buried in the ground. It may last for millions of years, but as before, the supply will eventually run out. We will eventually once again have to go find a new star to call our home. We can do this over and over again, but there is a fundamental problem with this strategy. Although new stars are constantly being born, there is a limited amount of nuclear fuel in the universe. Stars are powered by nuclear fusion, where atomic nucleuses combine together and are transformed from one element into another. As this continues, the atoms are eventually transformed into elements that are no longer useful for nuclear reactions. Eventually, elements useful for nuclear reactions will be depleted, and all energy in the universe will be dispersed. When this happens, no new stars will be able to be created. All the stars in the universe will go out one by one. What is shown here is based on the laws of physics as we presently understand them. After every star is extinguished, all life in the universe will end. However, our understanding of the universe is imperfect, and our knowledge is constantly growing. No one knows what we may discover in the future, and if this fate may yet be avoided.